Good afternoon to all of you. Myself, Dr. Jaishree Jain, as Associate Professor in AKGC Engineering College in CSE Department. So today we will learn about the backpropagation and stochastic gradient descent method, which is used in neural network classification. So this is the topic where we do the supervised learning. In supervised learning, the data is already labeled, and here that we have input data as a labeled data. So now we have to understand how this labeled data will be classified with the help of this technique, backpropagation and stochastic gradient descent. So firstly we have to understand what is artificial neural network. So the motivation behind this neural network approach is the simulation of the neurosystem of human brain information processing mechanism. So as a human brain work, we all know our human brain have the cells, and the cell perceive the information, and then they share the information to the other cell. So all over body information will be sensed by the human cell, and they perceive the information and then transfer the output. So this is the process. So here the structure is huge amount of densely connected and mutually operating processing units, that is called the neurons. So we will also just going to mimic the human brain structure in our neural network structure. So we have, this is the structure of human brain where we have the neurons, and they have many input and single output. So these are the dendrites where we have the getting the input, and after that all the information will be collected at the center of the nucleus, and then it will generate the output. So this is the output. So the input from other neuron determine whether the neuron fire, means all the information will get collected here, and then it will decide whether the what will be the output. Neuron fire means whether it belong to any class or not. So each input synapse has a weight. So each input where it is getting the information has the weight. Weight means the importance, or the it is a parameter, means ki if we have number of information, then which information is more sensitive or more important. So we have associate the weight on that information. So here we have the structure, we going to mimic the human brain structure here, and we have the label data. So in label data we have the features. So the features will be selected, feature is converted into the neurons. So we can say in one neuron, here we have the input I1, it means it have the one feature value. Like if we have age attribute, age feature, then it have the contain the any age value, like age value means 50 or anything. So second input is I2, third input is I3. It means we have three feature, and it is containing row by row. It will take the input, means if there are 1000 row, then one row at a time will be selected as a input parameter, and the weight will be associated with each and every input. Weight means we have the one random variable, and the value will be initialized at the starting when we initialize. These values will be initialized when we are going to start our training. So and next is the nucleus. In nucleus, this is the formula where we calculate the information. So it is the summation I j is equal to 1 to n wj and ij. So when this value will be compared with the target, so whether the value will be greater than 1 or less than 1, so it will be decided, and it will be checked, and when we can verify whether it belong to class 1 or class 0. So this is the process of neural network, and this is the statistics about the human brain. Total number of neuron in human brain is 10 raised to power 11, and connection per neuron is 10 raised to power 4. And signal sending time is 10 raised to power minus 3 seconds. Face recognition time is 10 raised to power minus 1 second. So this is one statistics. So the goal of this machine learning is non-linear classification. So this method is suitable for linear as well as non-linear classification. So it is very important where non-linear data can also be classified with the help of backpropagation technique. So basic idea is we have set of connected and input and output units where the connection has a weight associated with it, and it is generally used for pattern detection and machine learning algorithm and for build the predictive model for large data set. So it have highly accurate predictive model for large number of different types of problems. And here the some terminology like it has a connection. We have to build the connection between the nodes, and we have to decide the number of units in the hidden node or at the input layer, so that we can filter out the data and finally we will reach to the target. And training level, we have to decide number of rows or mini batch. We can decide if we have 1000 rows of data set, then we can decide at one time how much rows will be processed at one time. And model is built one record at a time. So I already told we take the input data I1, I2, I3 and we just select the feature, and from feature value we have the number of tuples, number of rows, and we will select, this is recursive process, so we will select the input data and just give to the network. So it is called as a feed forward neural network because we have two pass, forward pass and backward pass. In forward pass we just apply the, in forward pass we have three layer: input layer, hidden layer and output layer. So this is, we can say, hidden layer can be any number like 2 or 3 hidden layer or 4 hidden layer. It can be any, but there will be one input layer and one output layer. So this is the structure, and this value, this formula is already I have told in nucleus. We just calculate the NatJ. NatJ means it is the summation of input value xi and weight wij, and this is the weight of, this is the bias value, this is initial weight. Bias means we have some past experience or we have just past value. So initial weight will be called as a bias value. So Wj naught is the bias. So we will calculate it, and the output, when we create the input, this is the NatJ, f of NatJ, this is yj, and after that we will just apply the activation function to match that value with the any class. So for classification we have to use the activation function. So this is the sign activation function. So we apply this activation function on the net value, and if it is greater than 0, then we can say it will belong to class 1. And if it is less than 0, then we can say it is belong to class -1. Yeah, it can be 0 also. So we can take, we can just see here the value are actually at the range of 1 and 0. So it can be only 1 and class 0. So we can write here 0. So this is a sign activation function which will classify whether the output will belong to class 1 or whether it belong to class 0. So it is easy. We can, if we are providing the record of 20 rows, so we can easily find the output yes, no, or 1, 0, 1, 0. So it is very fast method, and the accuracy of the model will also have the high value. And next is sigmoid function. So this is another activation function we can use. So we apply this activation function on the net value f of NatJ, and this is 1 upon 1 plus e raised to power minus NatJ minus Tj. Tj is the target value. So this is the formula, and this is the graph here which will normalize the value between range of 1 and 0, and here we have the threshold 0.5. So if the value is greater than 0.5, then it will belong to class 1, and if the value is less than 0.5, then it will belong to class 0. So this is the method how we can activate the, actually it is activation function. So the name is to activate the outputs, to find the, to classify the, actually to normalize the output for classification. So next is we can say for binary classification we can use sign function, and for multi-class classification we can have the argmax. Argmax actually it is also the one kind of activation function. So it depends which kind of classification we are going. Argmax actually choose the maximum values. So it have discriminant function. And regression, we can use this model for regression also, for prediction also. So this already we have covered how we train the neural network. And online train, this have the epochs. Epochs I already told, we have to divide our data set into number of rows, and one or two or three row will be simultaneously will classify at one cycle, then another epoch, next row will be selected. So it will be in number of epoch we can calculate or classify the data. So we have two pass, forward pass and backward pass. In forward pass, we generally propagate the network. In forward pass, the input data will be passed through the hidden layer, and after hidden layer, it will pass through the output layer, and then activation function will be applied to check whether output will be fire or not, whether it belong to any class or not. And when we find out the output, then if it will deviate from the target or it have some different value, then it will be the error or loss function. So for minimizing that, we have to update this weight. In backpropagation, this is very important. We have to update the weight which we have taken at the initial level random value. So because of random weight, the error will be there. So we have to minimize the error by updating the weight. So we have to propagate back the error signal for each hidden neuron. So it will be backpropagate means output to hidden layer or hidden layer to input layer. So here we have the algorithm of backpropagation. So how it will work? We have two steps here: the activation of hidden unit instead of activation of input value. So activation function will be applied on both layer, hidden layer as well as on output layer. So this is the connection. We have the input vectors x1, x2 up to xn. We have the weight vector. These all are in the form of vector. And here we have the weighted sum, where we have to calculate the net j. And after that, we have applied the activation function, and this is the bias, and activation function will be applied here, either sigmoid or sine function, then we will get the output. So this is the structure of neural network, how it will work this way. So we have input layer, we have weights associated in the branches, and here we have hidden layer and we have weight associated on the branches, and we have the output layer. So firstly, we have to initialize the network with random weights, and for all training case presenting input to the network. So firstly, we have to select the input, then we have to just initialize the weight, and after that we have to process it and reach to the hidden layer. We have to propagate that into the hidden layer, and the output of the hidden layer will be the input for the output layer. So the algorithm is like this. This is the epoch. In one epoch, we have to forward the network and back propagate the error. This is one epoch, then second epoch. So we have to repeat it until we get the accurate result, until we will get the accurate value of the output. So how it will work? So compute the, this is, I actually just going to the algorithm. So this is backpropagation algorithm. Here we have input, we have taken input as a data set and learning rate of the network. I will tell where learning rate will be used to update the, actually to update the weight, we have used the learning rate. And output is the trained neural network. And what are the steps? We have to initialize the all weight and biases in the network with the any random value. And then while terminating condition is not satisfied for each training tuple, means I already told we have to select the number of rows 1, 2, 3 or 4. So propagate the input forward. So we have at the first layer, we have input layer. So where input is directly connected with the hidden layer with the help of some weights. So here we have weights W1, W2, W3 and W4. And here we have the output layer, and at output layer, from hidden layer we will just approach to the output layer. This is hidden unit 2 and output layer 1, output unit 2. Input unit 1, input unit 2. This is the network, and in this network, in first step, OJ means output of this layer, this OJ. This is directly from input. So IJ will assign to the OJ, and then we will calculate at the output will be what? The weighted sum of the input layer. So weighted sum Wij into Oi plus theta. Theta is the bias. Theta is the bias. So here we will apply here the bias B1 or theta 1 or B1, it is, we can take any value, or beta 2 is for, B2 is for output layer. So at hidden layer we have apply one bias B1, and for output layer we have apply one bias B2 here. This is a past value, or we can say previous value. So we have to add this bias here in the weighted sum. So this is a formula for calculating the output at the hidden layer, and this output will be the input for this hidden layer. So this is, we can say this is net H1 actually. Net H1. If this node is H1, then we can break this node for in two parts. First is input part net H1, and next is output part out H1. So at net H1, this is the value of net H1 is equal to summation Wi into I plus theta I. This formula is for net H1. Fine. And then we have applied the sigmoid activation function, and this is the formula for output. So out H1 will be sigmoid activation function 1 upon 1 plus e raised to power minus net H1. So this will be the formula for calculating the output, or sigmoid activation function will be applied here. So we will get here, this is the out H1. This is the output of this layer, but this is input for the output layer. And then backpropagate the error. This will be calculated, same will be repeated here at the output layer. Next is the backpropagation, when here target will be given, like we can take the example of one example is there. So this is the example. So this is a whole network where we have input value 0.05, we have some weight value, we have some hidden unit, bias value here, and output, and this is a target. This target T1 and this is target T2. So we have two value 0.01 and 0.99. So here we calculate, when we here calculate out O1 and out O2, then we will compare it with these value, and what is the difference between these two values is the mean square error, means target minus out O1 or out O2 square. So this is the loss function, this is the mean square error. So after in the forward pass we calculate the input and output at each layer, and at the output layer we compare this output with the given target value and thus just calculate the error. So this is the loss function where we calculate the error. Fine. So this is the forward pass, and to minimize this error we have to just backpropagate here. So for backpropagation we use the partial derivative, that is del E upon, we have to update the weight. So this update delta, this is the W5. So we have to update the weight firstly. From backpropagation we just reverse the process from output to input. So firstly we have to update the weight of output layer. So we have to update first weight is W5. So we have to calculate the partial derivative. This is we call the gradient. This is a gradient or loss function. Gradient means slope. So because slope, what is the meaning of slope here? We are actually mapping these input parameter. This is the error and this is the weight. So if we map this, this will be, we will get this like this. So a point will just, if error is weight is low, then the error is high. So we have to just calculate, this is the slope actually, this is the negative slope and this is the positive slope. So this slope we have to minimize this error into 0 level. So this is 0. So if we are getting the point here, so we have to minimize it. So weight value will get decrease here, and here we have to increase the weight value, and here we have to decrease the weight value. So this function del E upon del W, if it is greater than 0, then we have to decrease. We have to decrease it. And if it is less than 0, then we have to increase the weight. So what is this called is the delta W. We have to calculate the delta W, and after calculating the, this is called as delta W. This is delta W. And after getting this value, we have to just decide whether we have to update the, whether we have to increment this weight, means old W5 plus is W5 minus eta del E upon del W5. This is the formula for updating the weight. So we have to decide whether we have to subtract or whether we have to add. So here we can use, we have to compare what is the value of this function. If it is greater than 0, then we have to apply the above formula, this one. And if it is less than 0, then here we apply plus sign here. We have to increase the weight. So this is the value back propagation. So how we will, just question is how we have to calculate this. So this will be the chain rule. So how we will calculate it? We just divide this O1 node into two parts, net O1 and out O1, and just back propagate the error. Here we have the error. So this is del E upon del W5 will be breaked into three parts. We can't directly move to W5. We have to propagate it here to here, here to here, and here to here. So it will be del E upon del out O1 into del out O1 upon del net O1 into del net O1 upon del W5. So this is the chain rule. So we have to calculate the partial derivative of this one, partial derivative of this one, and partial derivative of this one. When we calculate the partial derivative of all these three, then we multiply it together and just calculate the value of W5, this loss function. So this is a method how we calculate this, and after that we propagate. Similar way we calculate it for W6, W7, and then we calculate same process from H1 also. Means we divide this into two parts, net H1 and out H1, and from here we proceed from here and from this location to this and update the weight delta W1. So all this process will have to be followed. And so these are the calculation how we calculate this. Firstly, we have to calculate the net H1. Net H1 is W1 I1 into plus W2 I2 plus bias, and we just put the value from that numerical. So W1 I1 plus W2 I2 plus bias B1. So we will get the value of net H1. Similarly, we will get the value of net H2. And what is out H1? Out H1 is the sigmoid function, 1 upon 1 plus e raised to power minus net H1. So whether what is calculated here, this value put here, and we will get the out H1 value, this one. So this is the process. Similar, we calculate net out H2, and similarly we get net O1 here. In net O1, what will be the output? That is multiply with 8 weight, that is out H1. So the output is this layer is out H1. So out H1 multiply by W5 plus B2. Similarly, out H2 multiply by W7 and B2. So the output of previous layer will be the input for the next layer. So here we calculate this. So we have to put the value of out H1 and out H2. Weight is already given, bias is already given. And what is out O1? This value will be put here at exponential, and we can calculate the value of out O1. So this is the way. Similarly, we get the out O2, and then we have to calculate total error, that is 1/2 target minus output square. Here we have two error, EO1 and EO2, and total is EO1 plus EO2, this one. So this is the formula. First we put for out O1 and next is for out O2. Just calculate this, and this is the error 0.298. So this is forward pass, and in similar way now we have to backward perform the backward pass. This chain rule I already told you. So we have to calculate del E total upon del W5. We can't directly reach to W5. So first will be out O1, then net O1, and then W5. So we have to calculate this. For this I already told, we have to just repeat the this is a chain rule actually. So where we get the value. So first is the del E upon out O1. Here we have the error formula this. So we just write this formula here, and we have to differentiate it for taking the partial derivative. So this is the function 2 into 1/2, this 2 minus 1, and we are differentiating with respect to out O1. So this value becomes -1, and this is constant, this becomes 0. constant of differentiation will be 0. So we will get the value here, del E upon del out O1. Similarly, next is del out O1 upon net O1. So what is the formula of out O1? This one we will put here, and we just get the value here out. We have to just calculate the actually differential of this. So this is step by step. If we do, then we will get this formula, out O1 1 minus out O1. So value will be this, and next is net O1 upon W5. Net O1 formula is this. So with respect to W5, we have to differentiate it. This is constant, this becomes 0, this becomes 0, and the value will be here 1. 1 into out H1. So the formula is out H1, the value will be already calculated. So multiply, putting all together here, and we will get the value of loss function, that is 0.082. Now we have to update the weight. So what is the formula for updating it? This one. So this will be put here, and eta is 0.5, this is learning rate, and this is old weight, and we will get the updated weight. So initially we have taken weight 5 value 0.4, but it should be 0.358. So we have to update the weight. In similar way, we can update all the weight. So this is the back propagation, and after that we will repeat this until we just close to output. Similarly, we will get the partial derivative at hidden layer also. So we have to update weight W1, W2. Here this weight also we have to update in similar manner. So this is the process how to update weight W1, W2, and at the end we update all the weight here, and at the end the final value will be where we have to stop. We have to stop. The final output is 0.1 here. So we will get the output here, two output, 0.015 and 0.98. So this is near about 0.99, and 0.015 is near about 0.01. So where we get these out O1 and out O2, then we can stop the training. So this is all about the back propagation.